And we are live, which is very good.
Yep.
Let's do that. Good. Well, welcome to the latest webinar from Endress+Hauser, the hidden impact of maintenance on sustainability performance. I'm your host, David Hull. Founded in 1953, Endress+Hauser is a global leader in measurement and automation technology for process and laboratory applications. Maintenance is rarely the first area organisations associate with sustainability performance, yet the way equipment is maintained has a direct impact on energy efficiency, operational resilience, and long-term environmental performance. In many industrial environments, hidden energy losses and avoidable emissions are not caused by major system failures, but by small inefficiencies that develop over time due to reactive maintenance, inaccurate calibration, and inconsistent monitoring. These issues often remain unnoticed until they begin to affect productivity, energy costs, and of course, sustainability targets. In this webinar, we explore the often overlooked relationship between maintenance and sustainability performance. It will highlight where the hidden inefficiencies typically emerge, why accuracy measurement and preventable maintenance are more than ever a practical action organizations can take to improve both operational and environmental outcomes. What I would say to everyone is thank you for joining us today. Do remember that you can ask us a question. There's a box at the bottom of your screen. So if you do have a question for our guest today, then please do use that box, and I'll put that to our guest. And of course, our special guest is Dhiren Naidoo, the service portfolio manager for Endress+Hauser. Well, welcome, Dhiren.
Yeah, good morning all, or an afternoon if you're seeing us from around the world.
Absolutely, yes. I think it's an interesting one, this, Dhiren. I was looking at my notes a few days before this in preparation. I think it's a very interesting topic that I think a lot of us really don't take enough notice of, I think.
Yeah.
But absolutely is part, I think, of every process manager's portfolio. Pay attention to what maintenance and sustainability. How do those two things connect together? It's a very interesting topic. I think that's reflected in, I think, the number of people that have joined us today. So just to reiterate, everyone, if you do have a question for Dhiren, then don't hesitate to put that in the chat box, and I'll try and put that to Dhiren as we go. There will be some time at the end also for questions if something pops into your heads towards the end of this webinar. So, but if there's anything you really you really want some insight into, then please don't hesitate to contact us. Well, Dhiren, you have a presentation for us today, so I'd like to hand the stage over to you for your presentation.
Yeah, and as you mentioned, earlier about sustainability and maintenance, you'd be surprised, and hopefully this presentation that I have just opens people's eyes to the fact that maintenance and sustainability is very closely linked. And whenever people think of sustainability, they think of the lights, the water, electricity.
Sure.
But actually, in the processing plant, you'll see as we get through the presentation that there are other factors that play around maintenance. So maybe let me just start with, why are we driving sustainability and the sustainability goals? Well, if I look at the UK context, and I know we potentially have audiences from around the world, and I'm pretty sure majority of countries have some sort of sustainability goal. In the UK specifically, there is a target to be net zero by 2050. We hope in Scotland to be 2045, and in Wales at least 90% to be by 2045. These are quite audacious goals, looking at the fact that a lot of our energy consumed is used using fossil fuels. A lot of processes are manufactured using carbon equipment, and to reduce this down really to be net zero, it's going to take a lot of effort to achieve these. So if we look at some of the sustainable goals that we have, especially in the UK, they talk about poverty, green action, all of these things. But I'd like to bring people's attention to point number 12, which is responsible consumption and production. This specifically relates to manufacturing and industrial plants around the world, as well as commercial buildings. So if you look at it, as well as the government mandating that they're sustainable goals, a lot of companies have also been incentivized to reduce their carbon footprint. And around 80% of companies, from our research shows, that they have some sort of sustainable goals to reduce, their overall consumption and to be
Yeah.
net zero. And if you look at it, we see projects around the world,
Mhm.
people putting solar panels. If you come and visit our Manchester offices, we just completed a project now where our entire car park is okay, fair enough. Yes, it helps shade our cars if when we do eventually get some sunshine, but
Sure,
when
sure.
it rains
Sure,
in
sure.
Manchester, it also covers our cars. But the
Sure.
main factor is it's generating energy for us, which is carbon neutral.
Well, do you think that's also something that is that's very interesting that we have an incentivized I guess government is moving forward with its green agenda, absolutely, but companies are reacting to that. But I think it's more important that companies understand that sustainability for them is very important. It's part of their strategy. It's not going to be something that is just
Yes,
mandated. You have to meet a goal. But I think businesses, yeah, we need to meet our responsibilities as stated by law. But really, it's also important for our business as almost as a differentiator. What are we doing to move ourselves to more sustainability? And if we're going to do that, what's that mean for detail? I think a lot of the detail they
yeah,
look at is maintenance, it's calibration. Absolutely, these elements
definitely.
really feed in massively to their sustainability goals.
100%. So, like, even if we look at, I'm using Endress+Hauser as an example. In our building alone, we have an energy monitoring system where we
Yeah, yeah,
monitor, the temperatures around the building so that we're not
sure,
overexerting the boiler.
yeah.
So the boilers are not running on the weekend; they're running only during the time when people are present in the office.
Simple things like that. Yeah, yeah,
Very simple, making sure that there's a presence sensor in meeting rooms, so air conditioners, and this leads on to the next slide, which is the major sources of energy waste in industry. And if you think of it, we when we walk around plants in industry, we always hear that hissing sound, or we see that big plume of white cloud appearing over the boiler house, and these are typical of compressed air and steam leaks. And
mm,
I'm pretty sure every single plant suffers with that. And if you
sure,
look at it, there's some sort of energy that's being put in place to actually generate this air
yeah,
or the steam, and it's just going into the atmosphere. For instance, you have poorly made seals and gaskets where you see leakage all
hmm
over the plant.
hmm
Inefficient or oversized motors. When last was a motor maintained, for instance? The bearings had a look, been looked at or lubricated, for instance. That heat that's generated because of the friction is wasted energy.
yeah,
Um,
sure,
opening and you have the typical, so like in the commercial side of the industrial plant, you have your office buildings, opening doors, leaving windows open. I've been in many meeting rooms where there's nobody's been in it, and the heating's been left on, and it's like a
sure,
furnace inside.
sure, sure.
Once again, wasted energy. But I specifically want to highlight, and we can go through all the examples, but I specifically want to highlight, poor plant maintenance and
Mm,
inaccurate and uncalibrated sensors are
big,
highlighted as serious major energy sources. Obviously, not low hanging fruits, because things like mandating people to open and close windows, shut off the air conditioning, we can do that. That's a low hanging fruit. Looking at plant maintenance is a really bigger scheme of things. There's a
absolutely,
lot of
yes,
thought processes, but it
absolutely.
it really it results in a lot of savings. And we'll go through an example where I can show you these savings.
Indeed.
So if you look at it, and that's why I say it's a broader topic, because what is classified as maintenance? What is physical maintenance in a plant? So I'm not talking about mechanical, I'm talking about pure instrumentation, because this is where Endress+Hauser's speciality is.
Hmm.
So if you look at maintenance is defined as a proactive approach to maintaining equipment and facilities by performing regular scheduled tasks to prevent unexpected breakdowns and costly repairs. What that means is it's like your car. Every year in the UK specifically, you have to take your car in for an MOT and a servicing, and that entails checking your tires, checking your oil, checking your water, making sure that that car is working to its prime condition. Because at the end of the day, it needs to keep its occupants inside safe. That's the purpose of a vehicle: get you from point A to B and keep you safe. In a plant, a flow meter's job is exactly the same thing. It's to ensure, and this is a flow meter example that I'm using. I can use other pressure, level, temperature, whatever it is. But
Sure,
for the
sure.
flow meter, it's to ensure the measurement or the product that's going through is measured accurately.
Hmm.
And the reason why you need to measure it accurately is because if you think of most plants, it's like baking a cake. It's a recipe. A
Absolutely.
recipe is involved. You
Sure,
don't
sure.
want to underproduce a product or overproduce a product because it
Mhm.
affects the quality and it leads to wastage on site. You want it to
Of
be
course.
perfect. And the instruments are basically the eyes and the ears of the plant because the operator sits in their operating station and whatever decision they make, it results from that instrument that's actually seeing
Mhm.
it or hearing it in the processing plant. And if that's inaccurate, you are making incorrect decisions, which then becomes a domino effect to, product recalls or product failure or even
For sure.
safety risks on site where you have wastage because the tank is overfilled because the instrument is measuring incorrectly.
You think also that a lot of, I guess, a lot of this conversation about sustainability and how that links to maintenance and calibration. Of course, the foundation of all that is is good data. I think
Yes.
what you're kind of saying is that really, if you're going to move forward with your your sustainability agenda, what that looks like. Clearly, you're going to have to look at your plant and your machinery and your process, what that's telling you. But ultimately,
Hmm.
it's the data, isn't it? It's looking at the
Yes.
information that's coming off off your sensors and interpreting that, I guess, within your sustainability goals. What's that
One.
telling? Yeah, and if you can understand what that data is telling you, surface some actions, it becomes I guess a practical application of the information that you're gathering. But I think ultimately, if you can do that well, if you grab I guess the correct data, then your sustainability goals are going to be met because you can understand
100%.
what's happening in your process.
Yes, 100% agree. Exactly what you're saying. And data is becoming more critical. In the past, when we started this evolution of instrumentation and measuring, it
Mm,
was a gauge. It was a physical indication in the plant to
absolutely.
gauge what was happening in the plant. Now there's so many parameters that an instrument provides.
Mm,
For instance, a flow meter can provide the viscosity, the density, if there's
indeed.
air bubbles in the line, if there's corrosion in the tubes, if there's buildup in the tubes, what's the temperature, all of these parameters are being measured. It's harnessing the data to make educated decisions based on that. Um,
We actually have an interesting
mm,
question from Sanath. They ask, what are the main causes of EFW incinerators exceeding their atmospheric emission limits? Does Hauser provide systems for gas monitoring from these types of process industries? That's a very
yeah,
interesting, wasn't it? How are you going to measure that? Yeah,
yeah, 100%. So we've just recently acquired a company or a part of a company that does gas emission monitoring.
okay,
So on the top, you see on the top of a lot of processing plants, even in energy from waste plants, there's a stack. So they're burning refuse, and there's
sure,
obviously stuff going in the air, methanes, ethanes, carbon, all
sure,
of
sure.
these, particles are being released into the atmosphere, and plants are being mandated to monitor this and reduce that amount of emissions going.
Yeah,
So
yeah.
the air that's being discharged from the process is a lot cleaner. And Endress+Hauser definitely has a solution with our Endress+Hauser gas measurement portfolio that can measure those types of equipment and make the decisions or to help the plant reduce their carbon emissions on site.
Fantastic. Sanath also goes on to ask about has the concept of rainwater harvesting been looked at within Hauser?
This is something that we are looking at. It is on
Mm,
our radar, especially being in Manchester. Solar was the primary choice, as I
absolutely.
said, to protect, not to generate
I'll
electricity,
tell
but to protect
everyone.
us.
Yeah, absolutely. When I was in Manchester a few weeks ago, it was raining.
It was to
It's
protect.
rain. I'm in the Midlands, and it's raining here. So I think rainwater harvesting, absolutely, the UK.
100%, yes. It was a priority for us to put solar. The next is looking at wind because in
Yeah,
Manchester we have a
indeed,
ton of wind, and
indeed.
obviously solar is dependent on whether we see the sun or not. Whereas when it's raining and windy, we can harness a lot more. So our next project is wind, and then we are looking at potentially rain harvesting, and then using that water, potentially cleaning it and using it to either water the gardens
Yeah, yeah,
or
yeah.
use it in some of our processing, like calibrating of flow meters, for
Yes, I
example.
mean that circular look at how sustainability work. That circular thing,
Exactly.
reusability, and how can we actually do that? What's that look like? For your business. I'd say, Stan, keep an eye on what's happening with really what the information on the Different Houses website. Clearly, all this will surface over time. But I
Yeah.
think both of those aspects of I guess sustainability, particularly when you're looking at I guess reusability
Yeah.
of an asset, whatever that may be, whether it's
Yeah.
incinerators or whether it's rainwater. I think that circular view is I think that's a foundation for all sustainability.
Definitely, and a lot of even the government is looking at a circular
Yeah,
economy in terms
indeed,
of using sewage water and reusing it into grey water applications. So it certainly is a topic for discussion. But I guess we digressing on this
indeed,
topic,
yes.
and we can go into many avenues. But if we could just focus back into under maintenance, what are the type of maintenance that are
Mm,
out there, and one that is particularly um, prominent in a lot of plants is the one right at the bottom, which is do nothing strategy, which
yeah,
is the reactive maintenance. So we carry on with our day-to-day plant, and
yeah,
when something happens in the plant, then we react to it, and then we perform the maintenance. And majority of plants around the world, I've noticed, have this sort of strategy.
yeah,
Um,
indeed, indeed.
you also have corrective maintenance. So a lot of plants will be, I'm using a dairy example.
Hmm.
So a batch of a particular milk has failed. So then they go and look back in the process, and they identify maybe it's a temperature probe on the pasteurizer.
Gotcha.
Okay, so
Yeah.
then we provide the corrective maintenance so that the batch then doesn't fail. You have condition-based maintenance, which basically means that if a device goes into failure or goes into error mode,
Hmm.
then we then perform maintenance accordingly.
Okay.
Um, the one which I call is a little glass ball is predictive. It's a very difficult for a maintenance. So you're trying to get that balance right. You don't want to over maintain, you don't want to under maintain.
Mm,
You want to maintain in the Goldilocks zone at the right moment
yeah, yeah,
before that device fails and causes quality issues. We wanna really, and this takes years to define that, because you have to do a lot of strategy. So you have to start over maintaining and then slowly slimming that back down
yeah, yeah.
until you get to the point where you start having problems in the plant, and then you increase it up again until you get to that Goldilocks zone, and then that's what you use as your
Ah,
maintenance
well,
strategy.
that's interesting again, isn't it, Dhiren? That Goldilocks zone, and you basically saying, well, predictive absolutely can be part of your strategy, but it
Hmm.
can a little bit like crystal ball. What's it going to do in the future?
Yes,
Yeah,
yes,
I think over time, if you gather the right data, you'll have enough legacy information to be able to make some pretty
yes,
accurate decisions, I think, and some
yeah,
accurate predictions moving forward.
yeah,
Yeah, something's happened,
100%.
like a sensor or a probe has failed. If you understand when that failed, why it failed, and all of the rest of it that goes into that, I think over time you have a baseline of information, and then that feeds into predictive, and that
Yes,
predictive over time will hopefully get more accurate, which of course is everything we want to do. We want to know, is that probe going to fail again in 6 7 weeks or 6 7 months? Will it fail under these conditions? If you can understand that information is gold dust when it comes to
100%.
predictive maintenance.
And what we're discovering more and more is, this buzzword around the world is cloud technology and
Indeed,
IoT and
indeed.
connecting of these devices to a cloud.
Yeah.
A lot of people are very skeptical about connecting things, but you and I, we have mobile phones, and we constantly connected to the cloud. Our information, our photos,
Mm.
our personal information is in the cloud, you know. And I'm not getting to the point where everything sits in the cloud. There's certainly critical applications where you don't want hackers potentially
Yeah,
to
yeah,
get in, and
yeah, yeah.
but at the end of the day, an instrument, you can't hack an instrument. It's the eyes and ears. It's not doing anything besides monitoring what's in the plant and analyzing that data. And potentially in the future, what you could do is, if you have a dairy plant up in the north of England and you have a dairy plant in South America, for instance,
Mm.
learning from those both dairy plants, because they copy and paste, learning from one another. What are the failures in South America? What have we learned in England? Learning from that, and then both plants being successful
Hmm.
in the management, because those plants are identical. So that potentially is the future in predictive maintenance as a strategy.
That's very interesting, Dira. Do you find that also with, I guess, with plants and machinery, which is, I guess, spread over large geographical areas? Let's look at, say, a sensor is the same. If it's here in the UK or somewhere in Europe or in Switzerland or
Mhm.
the Nordics, wherever. Once you understand, okay, how does that perform in that particular environment? That can all feed back into, I guess, a central database of information, which can obviously be
Yes.
hosted in the cloud. And then
Yeah.
you're into some interesting, I guess, process then, because then you can start looking at, let's look at this from, I guess, from a bird's eye view, because then you look at all of your plant, no matter where it is. You understand how, say, a sensor is performing in certain environments. That data then can be looked at remotely, And of course,
Yes.
I think every plant and machinery, I think every plant and process manager, can we do this remotely? Is this
Yeah.
possible? But of course, if you embrace what the cloud can do for you, not for everything, as you say, some
Hmm.
stuff still needs to be on-prem. I think,
Yeah.
I guess what Endress+Hauser, I think what you're saying is that it's kind of a hybrid approach. If you do
Yeah.
that, then it's kind of best of both worlds.
Yeah, definitely. And harvesting the data and analyzing the data, no offense to anybody, but I don't know what hacker would want anything to want to
Well,
monetize that sort of information.
absolutely, yes.
You know, but
Well, I'm,
it's
sh-
just
I'm
purely analyzing that data and building a puzzle around it,
mm,
linking the data points together to make a story,
indeed,
ultimately to achieve sustainable goals,
of course,
you know, and to achieve optimization in the plant, because
absolutely.
ultimately that's what we want to do. We want to achieve the maximum optimization you know, in our process plant. And I go back to the motor vehicle, for instance. If you look at when Henry Ford built his the first Model T car,
Hmm.
to the vehicles that we're driving at the moment, these cars that we are driving at the moment are at the peak of safety, at the peak of optimization, using the least amount of fuel to get us the most distance, you know, using hybrid approach. And this is the future of processing plants, is,
Hmm.
as you alluded to, it's a hybrid approach of dealing with things. And then the last one I wanted to talk about in terms of strategies for
Hmm.
maintenance is preventative maintenance. So
Yes.
a lot of plants focus on reactive, but there are equal plants that do preventative maintenance, which
Yeah.
is every year they have a list of equipment, and they, irrelevant of whether it's failed, irrelevant of whether there's a quality issue around it or whatever, we will maintain these instruments, which is a
Absolutely.
good strategy. It's a
Yeah.
good strategy
Sure. Sure.
because at least you're doing something about it. You know, it's a starting point. I would say post reactive maintenance, if you're making a decision, the first step is to identify those critical applications in your plant and then do predictive maintenance before moving into sorry, do preventative maintenance before going into predictive
Yeah,
maintenance.
do you also find, dear, that in hand with that is also, I guess, looking at, yes, the maintenance of I don't know, a valve, for instance, or whatever it is on your plant and machinery, but also, I mean, we've talked about sustainability and connecting that with, say, calibration, for instance.
Hmm.
It seems to me that's very important as well. Understanding what the baseline is for all of your components. Has that
Yeah.
moved? Because over time that can drift very, quite a way in some cases.
Yeah.
Do you feel that if you can understand what that predictive stuff is and what that kind of reactive maintenance is not really giving you, if you can move that to becoming more of a corrective maintenance, as you say, that's very important. That's a sort of
Yes.
behavioral shift, but also look at your calibration as well. That's very, very important,
Yeah.
because it kind of goes hand in hand
Yeah.
with just maintaining
Yeah.
whatever it is, with maintain the physical valve which is giving you the data.
Yeah. Correct. And a good point, because the next slide talks about calibration, because
Mm,
this is very interesting around maintenance. And one of the biggest thing that contributes to maintenance is calibrating of
great.
devices. And it's
Mm,
from the French organization, I'm not going to butcher the French version of it, but it's basically the International Bureau of Weights and Measures. And these are the guys that actually hold the kilogram, the meter standard, and
yeah, yeah,
we reference all our devices, all our measurements to those standards. And
indeed.
they define calibration as, you know, a documented comparison of a measurement device to a calibrated and traceable reference.
Sure,
What
sure.
this means is that whatever you're calibrating, it needs to be of a higher traceability or higher calibration. So if you're calibrating a Coriolis flow meter that has a zero point 0.5 accuracy, you would want to calibrate that Coriolis flow meter to a meter that's 0.4% accurate.
Hmm.
You know, anything that's higher accuracy, because what you're doing is you're looking at if that meter is starting to drift, and the moment it starts to drift, it starts to impart errors in the measurement, and
Indeed.
those errors then lead to wastage on site, etc. And I'd like to elaborate. A lot of people, a lot of companies sell calibration, but it's not calibration. So if you take a flow meter, right,
Yeah, yeah.
that's in line, yes, there's hassle to take that meter out. Somebody mechanical needs to take that meter out, right, and put it on a flow rig and calibrate it. But by doing that, you're picking up all the results. You're actually testing every component in
Hmm.
that meter. Putting a clamp on next to a flow meter, a clamp on is less accurate than a Coriolis flow meter. You're
Hmm.
referencing that Coriolis flow meter to a less accurate device, which means you are now forcing an error into the device because you are measuring it against a a less accurate device,
Sure, sure.
which then, because it saves you time and effort, that is not a calibration. And I need to make people aware of that. And I hope this filters through that a calibration is ensuring that that meter is calibrated to a higher standard than its actual design specification.
Yes, I mean you
Mm.
find that a great deal in, well, particularly in sensor technology, don't you? That it's, yes,
Yes.
it has a baseline, it has a I guess a maximum radium, a sort of maximum area of accuracy. But I think if you
Hmm.
can say to yourself, well, that's fine, but if we can go at an extra 10, 15, 20% above that, and we understand that the meter is now accurately calibrated,
Mm.
it gives us almost like a, it's almost like a buffer zone. We understand that that meter is calibrated to the, to the industry standard, international
Yes.
standards, but we're sort of giving ourselves a little bit of wiggle room. It's
Yes.
very useful then, because then you
Yeah.
understand, I guess, what that is. And you say, well, okay, then we understand how far away from standard that meter will potentially drift over time. Again, it's more data again. It's
Definitely.
information that feeds back, and of
Hmm.
course, accurate information from your sensors feed back into sustainability. You're using, less materials,
Definitely.
you're using less energy, the costs are reducing
Hmm.
because your meters are giving you accurate, accurate readings.
100%. And we also experience it a lot of times, and this is irrelevant of Endress+Hauser, who supplies calibration, services. A lot of customers will come to us and say, "Well, can't you just do a loop calibration?" And a loop
Yeah.
calibration basically
Sure.
means, well, we'll calibrate the output of the device.
Yeah.
Yes, that is a form of calibration, but you're only calibrating the output. If that device is
Yep.
measuring it correctly, calibrating the output is not going to affect or change anything. You need to calibrate the primary element and make sure the primary element, which is actually the thing that's measuring the product, is actually accurate.
Yeah.
And yes, as I said, these form part of maintenance. So testing the loop, verifying the system augments the calibration, and it tries and it highlights potential failures or potential areas of inaccuracy. But at the end of the day, calibrating the entire system is what you want to is the gold standard for calibration.
Yes, I think ultimately, don't look at a sensor in isolation. I think that's what you're saying.
Hmm.
Don't forget, these kinds of sensors are part of what can be some very complex process.
Yeah.
Um, Look at it in the whole, because it's kind of more of a it's more of a holistic look at your entire process and
Yeah.
how you're putting certain sensors onto certain areas. What's that going to tell you as you move forward? In fact, Sanath has come back with quite an interesting one. Does preventative maintenance also include custom spare stock subject to obsolescence? That's interesting, isn't it? If you're looking at what your sensor technology is going to do across your plant and machinery, are you going to build in, I guess, obsolescence that you understand? Again, does that feed back into predictive maintenance again?
100%. This forms part of a strategy in a
Mm,
in a plant. So you have maintenance strategies, and then you have strategies for when the inevitable happens and there's a breakdown. Do
indeed,
you not keep stock, which is a strategy as well?
indeed.
And then when that device fails, or devices or section of the plant fails,
Yeah, yeah.
and you can't produce, do you wait 4 to 6 weeks, 8 to 10 weeks for a new device to come, and then the
Sure,
plant sits
sure.
idling, and or you have product flowing out? Or do you have a strategy where you identify all the critical components in a plant, and then you keep those spares on hand, or you use the obsolescent devices. So another strategy is, if you can think of it, you have a lot of brownfield plants that have been
Yeah, yeah.
around for 40, 50 years. You
Sure.
can't go and refresh the entire plant with new instruments. As much as, yes, a salesperson like myself would love for people to buy
Please,
entire
yeah,
kits for the entire plant, it's not
indeed,
practical. There's no
indeed.
capex for it, right? But what you could do is you can take a section of the plant that's not as critical, right? You replace those devices, or you take the plant that is critical, you replace it with new devices, and the old devices you keep in spares. So if a device fails in the interim place, you know that these devices are still working. You replace it out with these older devices, and then you wait for the new one to be ordered. So that forms part of your strategy. So to reduce downtime, to reduce wastage, and potentially to support the sustainable goals in your plant.
I think that's right. I think you see that a lot across, as you say, a lot of processes which have been around for decades. I think what you're saying is that if you have a strategy where you understand what could fail into the future, it gives you a what can we call it? It's a fallback, isn't it? It's
Yes,
something you can fall back onto, and the practical application is your plant is still moving, it's still producing
yes,
content. Yeah,
exactly.
it's not have to be halted for any reason. But it's interesting you also say that looking at maybe specific areas, focus on those first. Don't think it's got to be a root and branch across your entire process. Now that could be crazy in
Mm,
some cases. But I think as we move forward with, or maybe with better sensor technology, more sort of data harvesting and all of that really good stuff, I think it's going to be an incremental move. So maybe in a few years' time, you've actually refreshed pretty much all your plant, but not in one go. I think try and take it
yes.
in small elements. What's likely to be a catastrophic failure in a certain area? Look at that first, I guess.
Yeah.
Look at what could happen. Can you keep spares on site? If you can, again, use some fallback if you're going to move to new technology, because again, keeps your plant moving.
Yes, definitely. And just to give an example for those that can't relate, it's like having a motor vehicle. If you look at a lot of the older vehicles, they have a spare wheel in the back, right?
Yeah,
It's not a full wheel; it's a donut wheel,
yeah,
but it serves the purpose to keep that car moving and keeping you safe on the road. Because you
indeed,
have this donut, or even
indeed.
I think the modern cars have eliminated that because they want to
Yes,
gain efficiencies, so they reduce the weight in the car. So what they've done is they've put a little bottle of that fluid that pumps up the tire, fills the gap, and it gets you moving going forward. So
indeed.
this is the strategy. You're keeping a spare in the vehicle to get you moving, because that the tire is a critical component to utilizing the vehicle.
Mm,
So I'd love to
indeed.
go into an example that we have learned and
Mm,
we've tried and tested before.
good.
So for those that are not in the food and beverage or dairy industry, I hope this still hits home with you. So if you look at a processing plant, right? So this is a typical dairy, and if you look in the middle here, this is a heat exchanger, right?
Yeah, yeah.
So if you look, you'll see that there's a little red line and a magenta box. That is a temperature measurement that we have, right?
Okay.
So in a heat exchanger, what you're trying to do is you're trying to either warm up the milk or cool down the milk, depending on where it was in the process.
Yeah, yeah,
And you're doing this either using hot water or you're using steam. Most likely you're using really hot water, right?
yeah, yeah.
In order to produce hot water, you have a boiler right at the beginning point, which either uses in a lot of third world countries, they use coal still.
Okay.
Some boilers use wood. A lot of boilers use natural gas.
Hmm.
Some even efficient boilers or more greener boilers use biofuels to
Okay.
boil.
Yeah, yeah.
And basically, it's a big kettle. It's
Sure, sure.
it's essentially it's a massive kettle, right? But in order to, if you think of it, it's a kettle the size of a house
Yeah.
that has to boil this water. So a lot of energy has to go into it to boil the water to create steam, right? This steam then needs to travel to a point that then warms up water, because generally an output of
Hmm.
a boiler is not hot water. The output of a boiler is steam that we use to heat up elements around the plant. So
Sure.
then we take this boiler, we have to heat up water, right, to a certain temperature. That water then needs to get transported across the site and eventually lands up to this magenta box over here, where you have hot water that's warming up, or in this instance, in this example, it's warming up the milk so that it keeps it. They call it pasteurization, which is basically
Yep.
it warms it up, overboils the water, so it
Hmm.
kills all the microbacteria in it, so that the milk doesn't get spoiled and it lives past its sell by date,
Ah.
basically. Right. So we took an example. Maybe I'll reach out because I'm talking to yourself, Dave. If this temperature probe is 1 degree out, how much do you think it potentially costs the plant?
Well, that's a very good question, because I have read that even a small shift can be massive, and
Yeah.
people don't really understand that it's a huge impact on plants. So I think everyone will be very interested when you tell us the number.
So in this instance, it's 29,000.
Jeez, that's crazy numbers, isn't it? Yeah,
29,000 because one
yeah,
degree out. And now
one
you
degree.
think of it, okay, what is 1 degree? Because this temperature probe, we simulated it and
Yeah,
we
yeah, yeah.
worked it out to be 1 degree out, right?
Sure.
1 degree out means that that boiler has to put in extra fuel, right, to
Indeed.
boil up this volume of water by that extra 1 degree. It then has to transport the steam that, remember, over time, because it's being transported, loses temperature,
Indeed.
right? So it has to overboil the steam. So it transports it to the heat exchanger that's warming up the water. That heat exchanger has to work a little bit more to pump more water through it to get that extra 1 degree.
I'm with you.
That hot water then needs to be transported again, so you're pumping more, your motor is working more to pump that water further to increase it by an extra 1 degree so that you can pasteurize it.
Yeah,
Now
yeah.
just imagine how many 1 degrees around the plant is incorrect,
Indeed.
and then
Yeah,
this
yeah, yeah.
cost then gets inflated very quickly, just purely by 1 degree. And
One degree.
I use 1 degree as a because, let's face it, it's not 1 degree. It could be two. It could be 5 degrees
Indeed.
difference
Yeah, yeah.
between your set point and what you're actually measuring.
Sure. Sure, sure.
And this cost, and that's temperature. You think you're on a process plant. You have pressure. You have flow. You have liquid analysis, which monitors the water quality, and using chemicals to ensure that that water quality is at a pristine. If
Mm-hmm.
that analytical device is incorrect, you're wasting chemicals to produce this clean water, so to speak. So my point being is that maintenance of the plant, calibrating of the plant is
Mm-hmm.
really crucial because it's the hidden cost in producing the
Yeah.
product at the end of the day. And you can waste a lot of money and energy around the plant because of these incorrect measurements.
Yes, I think that's right. I think if you pay close attention to this, you may be very surprised when you actually look at what your sensor technology is actually showing you. Is it calibrated correctly? Because if it isn't, you're kind of in the dark. You're using data which is inaccurate and making maybe quite costly decisions based on that. How do we change something if the data isn't correct? And of course, that feeds back into your sustainability goals and how are you actually going to achieve those. If the data you're getting is not accurate, your plant not only suffers, but you're also going to have to reevaluate really how you're going to meet those sustainability goals. So again,
Yes.
sustainability and calibration, they are very, very close bedfellows, which I think maybe a lot of process managers, I think, are beginning to understand that. But I think, as you've just alluded to, that practical example just shows you, well, it is an absolute massive impact on your plant if something moves by 1 degree. And as you say, it's probably going to be several degrees. So if that's the case, that's going to just compound the issue. So really pay attention to calibration, particularly on these kinds of these kinds of processes, because they can move. They're dynamic. They do move over time. It's absolutely important to look at your maintenance really as a sense of urgency. It's not a case of, well, we do that once a year or something and it's fine. Well, it probably isn't, and that's costing not just the bottom line for your business, but really that's going to impact on your sustainability goals.
Exactly. Exactly. So yeah, and I just hope that the audience focuses on maintenance going forward, and if they need any support, Endress+Hauser, we're more than happy to support with multiple strategies that we've learned in the past 70 odd years.
Yeah.
In this industry, we've learned a few things. So if you're not sure where to start, certainly reach out to us, and we're more than happy to support.
Yeah, that's absolutely right. Well, unfortunately, everyone, that's all the time we have for this webinar. I'd like to thank Dhiren for his insight, and also all of you for joining us today. As Dhiren alluded to learn more about how your business can improve its relationship between maintenance and sustainability performance, please do visit endress.com. Till next time, it's a goodbye from me, and it's a goodbye from Dhiren.
Yes. Bye.
Goodbye, everyone.